Okay, now in this mini lecture, this is what I call my story problem file, where I'm just going to start giving you data sets that kind of become story problems. Alrighty, and I've talked to some of the business professors, or just going from experience. I'm trying to show you how we would use these different inferential statistics tools. You know, whether it's in accounting or finance, marketing, or whatever. Okay, so we'll work with this first data set here. And real commonly, what happens in business, is we track two sets of data over some period of time. We keep track of how many units of product that we produce, and we also track our total costs. Now, accountants will come up with an approximation of you know, what are fixed costs and what are variable costs. But at the end of the day, we actually can use statistics to looking at the relationship between units produced and total cost to come up with quite an accurate estimation of fixed and variable costs. Okay. Now, I will tell you up front, we're going to run a simple regression here. But if you keep in mind, units produced are ratio and scale, total costs are ratio and scale. So we've got two ratio scaled variables here, and there's a number of things that we could do, but picking the right statistical test is a function of what's the question. So if we were only interested in whether these two variables are linearly related to one another, we would run a Pearson correlation coefficient. But in this instance here, we want to use units produced to forecast not only total cost, but to break our total cost down between fixed and variable. So that's what pushes us to drive towards the simple regression model. So we just click on add-ins, and we drag over to Megastat, and we drag down to correlation/regression, and then we drag over and down to regression analysis. Okay, so this should be old hat to you. And for our independent variable, well, we're going to use the units produced. So notice I highlight the column header as well as all the data. And for our dependent variable, we're going to forecast costs, total cost actually. So I highlight the column header and all the data. Since we're only doing simple regression, don't really need to ask for anything down in this part of the table. Notice we're working with a 95% confidence level. So I click on OK, and I get my results. First thing I do is I look at it and go, oh my gosh, an R squared of 98%, that's outstanding. That's outstanding. Not surprisingly, my p-value is very, very small. Okay? And then I see here that A, which is my y-intercept, is $23,641, and B is predicted to be $10.43. So we can build the model, total costs, equals $23,641 plus 10.44 times units produced. Okay, let me make this a little bit bigger here for us. Okay, so total cost, that's our dependent variable. This 23,641, that's how much money we're going to spend irrespective of how many units we produce. In fact, if we produce 0 units, we're still going to spend $23,641. So this becomes our estimate of the fixed cost. And then $10.44 becomes our estimate of the variable cost per unit. Okay? So total cost is equal to $23,641, our fixed cost, plus $10.44, our variable cost per unit, times the number of units produced. And that comes from this table right here. Okay? And if you don't run into this in AC 204, I can tell you that for those of you who are accounting majors, you'll run into it in advanced cost or advanced management accounting. Okay? Now, the one thing I do want to make mention here, though, and remember, we had a great R squared, 98%, okay? The one thing I do want to mention though is this $10.44, that's just a point estimate. And we can look over here to our 95% confidence interval, and we can see that we're 95% confident that the true variable costs are somewhere between $9.20 and $11.68. Okay? So even though we talk as though our variable costs are $10.44, I want you to keep in mind that this is our point estimate, and that our interval estimate really ranges between $9.20 and $11.68. And that's with a sample size of 10. Okay? Imagine if we had the same data, but we had a sample size of, I don't know, 20 or 25, this confidence interval would get even more narrow. Okay? So that's using the simple regression model to forecast this data. Now in the next mini lecture, I'll apply the same process to this data here. Thank you.